To prevent various troubles in the ceramo-metal process, research was continued for about 10 years until the latest solution was made available as we present here, Noritake Super Porcelain EX-3. The researcher, Noritake Company Limited, offers us this EX-3 porcelain backed by its 90 years of technology in ceramics. First, let us have a brief view at Noritake Company Limited. Noritake Company Limited has three main divisions, among which the tabletop group is famous worldwide. Not only in the United States, the high-quality Noritake tableware is also favored in Europe, Japan, Southeast Asia, and many other countries. The second division is the Industrial Products Group. As the leading company of grinding tools and grinding materials in Japan, Noritake makes continuous contributions to modern automobile industry, steel industry, and other main manufacturing fields. Here we come to the third division, the Electronics and Ceramics Group. The electronics section ranges from fluorescent display tubes to other electronic products. And the ceramics section offers advanced ceramic products such as alumina and zirconia, and industrial equipment such as far-infrared ray heaters, industrial kiln, and so on. Based on the know-how of these three divisions accumulated through the years, the Noritake Super Porcelain EX-3 is introduced. Let us examine the manufacturing process of Super Porcelain EX-3. 90% of the Super Porcelain EX-3 shows the same composition as that of feldspar, but EX-3 porcelain actually has no relation with natural feldspar. EX-3 is a synthetics at an extra pure reagent of more than 99.99% purity. The reason is that the natural feldspar contains ferrous and other impurities which may cause color discrepancy and quality instability. As you can see, the melted glass phase of natural feldspar reflects a blue-gray color shade. Compared with the natural feldspar, the artificial feldspar is synthesized under high-purity reagent. The glass phase shows a transparent color shade. EX-3 produced under synthetic process assures a constant quality. Next, we will go on to the features of Super Porcelain EX-3. First, outstanding resistance to fractures. Cracks occurring in the porcelain baking process are mainly due to the incompatibility of thermal expansion coefficient between alloy and porcelain, and the continuous variation of porcelain thermal expansion accounts for the discrepancy. Look at this graph. It shows the curves of porcelain thermal expansion. The line in red indicates the change of thermal expansion when porcelain is cooled down at room temperature right after baking. The black line indicates the thermal expansion curve of porcelain annealed in the furnace after baking. Thermal expansion of porcelain varies drastically depending on different cooling speeds after baking. In addition, the discrepancy of thermal expansion between porcelain and alloy adds to the crack occurrences. This graph reflects the effect of cooling rate to thermal expansion after porcelain baking. Q indicates quenching, 10 indicates 10 minutes cooling, and A indicates cooling more slowly. It can be seen clearly that for the porcelain of other companies, the slower the cooling rate is, the larger the thermal expansion will be. But porcelain of Noritake shows little variation. What's more, porcelain thermal expansion varies even with baking repetition and at time of post-soldering. So we can say that the variation of porcelain thermal expansion is the principal cause of fractures. Here is another graph showing the thermal expansion curve of Super Porcelain EX-3. The same as the previous graph, the red line indicates the changes when porcelain is cooled at room temperature right after baking. The black line indicates the annealing in the furnace after baking. Porcelain thermal expansion shows few changes despite different cooling speeds. Needless to say, thermal expansion reflects few influences of baking times and post-soldering. As shown above, Super Porcelain EX-3 succeeds in the stabilization of thermal expansion, which assures no occurrence of cracks. The second feature is no greenness on the silver alloy. Let's look at the experiment with test pieces. 5 milligrams of silver powder is placed on each test piece after condensation and baked. Here is the result. The upper array is the porcelain of other companies baked without silver powder, and the lower array, which show apparent greenness, is the same test pieces baked with silver powder. Contrary to the first case, test pieces of EX-3 show no greenness. Now we do the same test on a real ceramo metal crown. The right piece is an alloy with 28% of silver, and the left nickel chrome alloy without silver. the color shade turns green on the silver alloy. Look at the test with EX-3, the same as the above. The right piece is the alloy with 28% of silver, and the left, nickel chrome alloy. No greenness appears on the silver alloy, and the color shade reflects exactly as expected. The third feature is, EX-3 reflects the same ideal fluorescence as that of the natural tooth. This is the observation under ultraviolet rays. On the left, the natural tooth shows white-blue fluorescence. Right beside it, the ceramo-metal crown made of EX-3 shows similar fluorescence, which assures natural appearance wherever it is. Crowns of other companies show apparent difference from natural tooth. In a word, EX-3 is named for the above three features. Now we would like to introduce you to the attributes of EX-3 in detail. EX-3 is classified according to the Vitalumen shade guide. Please look at its opaque. It consists of 16 colors: body, 16 colors, enamel, 3 colors, and translucent, 3 colors. Translucent is arranged according to translucency. T0 shows the highest translucency, then T1 and T2 show the lowest translucency. For cervical, 4 colors are available: CV1 for the shade of A system, CV2 for B system, CV3 for C system, and CV4 for D system. The cervical may be applied separately or mixed with body onto the cervical. Modifier is composed of 11 colors. For partial color on the crown, modifier may be applied separately or mixed with body, enamel, or translucent porcelain. Opaque modifier has 17 colors. It can be applied on the opaque separately or mixed with opaques. Opacious body has 18 colors, all of which show medium translucency between opaque and body. To mask the reflection of opaque with a thin layer of porcelain entirely or partially, or in the case of thickness discrepancy between pontic and abutment, opacious body is applied to the root of the pontic. The special color OB enamel of opacious body is applied on the thin porcelain tip of abutment, and OB cervical is used in accordance with cervical D2, D3 of the Vitalumen shade guide. Over the baked opaque, build up opacious body of 0.1 mm thickness. After baking, build up body and enamel consecutively. Add-on porcelain has 2 colors. Minimal buildup of add-on modifies the deficient part after morphological correction, and the baking goes along with glazing. If the porcelain buildup shows some deficiency after morphological correction, perform the buildup again with enamel and translucent porcelain. Of EX-3 porcelain is a 2-layer structure of body and enamel after opaque baking, and there is also no inconvenience of the 3-layer buildup by body, enamel, and translucency. Now we will move on to the buildup and baking steps of EX-3. For the metal framework made of precious alloy or semi-precious alloy, grind it with carbide burr or alumina point for the modification. The grinding with the carbon random point may cause porosity upon porcelain baking. For the nickel chrome alloy, use the carbon random point for modification. After the modification, sandblast the frame surface with 50 micron aluminum oxide. Here is the picture of the metal framework after treatment of the carbon random point. And as the comparison, here is the picture after aluminum oxide sandblasting. The minute convexes and concaves formed by the aluminum oxide sandblast increase the contact surface between metal and porcelain, which accounts for the strengthening of bonding, so it is an indispensable process. For the gold alloy, sandblast it with glass beads. Aluminum oxide sandblast on the gold alloy may lead to bubbles upon porcelain baking. Then, put the metal framework into the acetone or alcohol liquid. Clean it for 10 minutes by ultrasonic wave. Follow the instructions of the alloy manufacturer for degassing. Degassing is essential because it strengthens the wetting between alloy and porcelain. Then, moisten the surface of the metal frame gently with a wet brush. Scoop the opaque powder onto the palette and mix it with opaque liquid. Build up a thin layer of opaque so that the metal color can just be seen. Now we move on to the first baking. Dry the piece for 3 minutes. Start the baking from 1202 degrees Fahrenheit and raise the baking temperature at 99 degrees Fahrenheit per minute until it reaches 1760 degrees Fahrenheit. This first baking is necessary to strengthen the fusing between alloy and porcelain effectively. Suitable baking of opaque will result in the slight luster on the opaque surface. The second application of opaque is to build up a layer of about 0.3 millimeters to cover the metal color completely. And then condense it slightly with a hemostat. Then dry it for about 5 minutes and at 99 degrees Fahrenheit per minute, raise the temperature from 1202 degrees to 1760 degrees to fulfill the baking. Above is the summary of powder opaque application, but our paste opaque demand is increasing drastically. Let's look at the features of EX-3 paste opaque. First, the application is simple. Even a novice can achieve an even thickness. Second, because of its stronger covering than that of powder opaque, 1/2 to 1/3 thickness of that of the powder opaque can cover the metal color completely. Third, it prevents the occurrence of black line at the margin. Since there is no need of water control, even a long span bridge can be created with even thickness. Powder opaque application is also possible over the baked layer of paste opaque. Opaque shows no color shade change even after repeated baking. No greenness occurs even with the application on silver alloy. Fractures are reduced due to the excellent fusing strength. The feature of fluorescence assures its natural color shade under various illumination. This picture shows the comparison of paste opaque and powder opaque after baking. Paste opaque gains the same effect with about 1/3 thickness of powder opaque. The thinner opaque layer leaves more space for enamel buildup and makes it easy to regain the color shade of ceramo metal crown. Up till now, gold paste is applied to prevent the black line, in other words, the phenomenon of a dark color shade at the margin. But the problem lies in the weak fusing strength between gold paste and alloy or porcelain. Paste opaque of EX-3 can be easily painted right up to the gingival margin and shows very little shrinkage even after baking. No black line appears on the margin. Therefore, even without the application of gold paste, margin color appears bright. Here we come to the items of paste opaque of EX-3. The paste opaque basic kit consists of 16 colors according to the Vitalumen shade guide, 1 color of base paste and 2 pieces of paste opaque brush. Furthermore, a paste opaque modifier kit is also available. It consists of 8 colors and 1 modifier liquid for dilution. Modifier can be applied as the mixture with paste opaque of each shade or separately at some parts. The seal on the knob of the syringe gives us the reference of modifier color shade. For the partial painting of modifier, it is recommendable to apply with a fine line top brush. Now we move on to the handling of EX-3 paste opaque. Squeeze out the paste opaque from the syringe and load it onto the palette. For a general shade, apply the paste opaque as instructed, but for the application on the alloy containing 75 to 80% palladium, base paste BA is preferred. The reason is that the alloy of palladium has copper as a component, so BA is applied compatibly to prevent greenness caused by copper. Now we come to the first application of paste opaque. Use only dry paste opaque brush. Clean it with water for every color alteration and get rid of water before reapplication. Also, keep the metal framework free from water. Scoop paste opaque or base paste with paste opaque brush and brush an extremely thin coating over the external surface of the metal frame. Proceed with the coating until 70% of metal color is covered. Check if there is any contamination of paste opaque on the inner surface of the metal framework. Get rid of the contamination with clean and dry brush. For the baking of paste opaque, set the idle temperature at 932 degrees Fahrenheit. For the first baking of paste opaque, raise the temperature from 932 degrees to 1796 degrees at the speed of 117 degrees per minute. Then hold it at 1796 degrees Fahrenheit for 1 minute at room atmosphere. That finishes the first baking of paste opaque. Suitable baking reflects the slight luster on the porcelain surface. Now go on to the second application of paste opaque. For the second application, paste opaque of each shade can be applied even on the surface of base paste by first application. Apply with paste opaque to cover the metal color completely. Clean the inner surface of the metal framework if there is any paste left. The program of the second baking is the same as that of the first baking. Here is the paste opaque after the second baking, the same luster as that of the first baking. And we would like to remind you the usage remarks pertaining to paste opaque. First, liquid separation may occur during the stocking of paste opaque. Squeeze the paste opaque from the syringe, and if there is any separated liquid, dry it off with tissue paper before application. For high-sticking paste opaque after a long period of storage, mix it with modifier liquid, but remember not to dilute excessively. Extreme dilution may cause shrinkage fractures after baking. Third, keep the brush dry for application. Paste opaque application may become difficult for random brush application. Number 4, keep the paste opaque away from direct sunlight and store it in a cool and dark place. Number 5, remember to seal the syringe with a silicone cap after application. Number 6, do not mix use with paste opaque made by other companies. Number 7, as the idle temperature is set at 932 degrees Fahrenheit, the temperature of porcelain furnace will not be higher than 932 degrees, so set the metal framework on the table of the porcelain furnace. No combined application of modifier if base paste is used for the first coating. Modifier may be applied with the combination of shade paste for the second coating over base paste. Ceramo metal restoration normally causes aesthetic problems such as graying at the margin and gingival recession. Therefore, demand for margin porcelain is increasing. Let's discuss the technical procedure of margin porcelain. The margin porcelain of Noritake EX-3 consists of 13 basic colors. The colors of C1, C3, and D2 are not included. If necessary, mix MDL, the dilution powder, with C2, C4, and D3 respectively at a ratio of 1:1, and these three colors can be presented easily. MRP is a kind of retouching powder for modification of margin shrinkage after glazing. Margin modifier consists of 5 colors which are mixed with margin porcelain of each shade. Next we come to the application of margin porcelain buildup. Shoulder and heavy chamfer are the suitable abutments for porcelain margination. Porcelain margin on the abutment of bevel shoulder and chamfer are too thin, which may result in easy cracking and unnatural color shade. For the wax up, refer to the same tooth on the opposite side. For the cut back, cut from about 1/3 of the shoulder on the labial margin. To guarantee the strength of the porcelain margin, keep sufficient wax on the shoulder. For the narrow shoulder, build up as illustrated in Graph 2. The compatibility of porcelain margin and metal framework on the lingual side after casting should be checked with caution. After the metal modification, go on to the aluminum oxide sandblasting, cleaning, and degassing. Next, the baking of opaque. Coat the die with porcelain separator. First coat with Noritake porcelain separator A. After 1 to 2 minutes, separator B. Build up margin porcelain before the separator is dried completely. Mix margin porcelain with distilled water or forming liquid. Build up margin porcelain uniformly on the cervical. After slight condensation, place the restoration on the die and press gently with a spatula. Condense again with an instrument. Remove excess margin porcelain with a dry brush. Twist the metal frame slightly and remove it from the die carefully. Check if there is any margin porcelain residue on the inner surface of the metal frame. Remove the excess away by a dry brush. After drying at the furnace table for 5 minutes, run the first baking of margin porcelain from 1202 degrees Fahrenheit to 1733 degrees Fahrenheit. In case of a deficient buildup after the first baking, wet the die with porcelain separator B for the second buildup. Follow the same program of the first baking again. Check the baking status of margin porcelain from the inner surface of the metal framework. Check if metal and margin porcelain join smoothly. Now the next step, the buildup of body porcelain. Cervical porcelain is not always necessary for the cervical. It will be helpful only for thick color density. Cervical porcelain is applied exclusively as the mixture with body porcelain. Refer to the color combination table for mixing ratio. Body and cervical porcelain should be mixed by forming liquid. On the cervical and proximal portion, build up with body porcelain or the mixture of body and cervical porcelain. Insert the metal framework onto the tooth abutment after adequate condensation. Mix A3B of body porcelain with the forming liquid. Build up with body porcelain the same size and shape as the same tooth on the opposite side. To prevent shape collapse during cutback, build up a little bit thicker on the lingual side. Please be reminded that the minimum thickness should be no less than 0.2 millimeters. After the completion of configuration, tap the mold with a condensed hammer. Remove the diffused water with tissue paper immediately. Repeat this process 2 or 3 times. Cut back the proximal area. Cut back up to 0.5 millimeters more from the marginal ridges on both mesial and distal. On the labial side, mark slightly the guideline on the 1/3 from the incisal edge and 1/3 from the gingival. Cut back 1/3 to the incisal edge. Cut back the central 1/3 of the labial. Observe from the tip of the incisal edge, you will find that for the space of enamel buildup, the incisal edge is thinner than that of the adjacent tooth. Confirm the position for mammalian structure on the incisal edge. Divide the incisal edge into 3 parts and carve out the mammalian structure. Finally, check the thickness of body. The minimum thickness of body is 0.8 millimeters. For a deficient part, additional buildup is necessary. Mix the enamel porcelain with forming liquid. Build up the enamel porcelain up to the cervical. With the consideration of baking shrinkage, build up 10% bigger than the same tooth on the opposite side. And then proceed the condensation the same as before. The basic buildup of EX-3 is 2 layers of body and enamel porcelain. For 3-layer buildup, build up the enamel onto the 1/3 portion of the incisal edge, and then coat the whole surface with translucent porcelain. The translucencies are arranged as T0 is greater than T1 is greater than T2. For the lingual side, smooth the surface by spatula. Extend the buildup of enamel porcelain to lingual. When the proximal is split after buildup, the layers of body and enamel can be seen clearly. Remove the metal framework from the die and build up the enamel porcelain on the proximal. And then the same condensation process as before. For the first baking of body and enamel porcelain, first dry the piece at the table of the porcelain furnace for 7 minutes, and then bake it from 1112 degrees Fahrenheit to 1706 degrees at the rate of 81 degrees per minute. The above baking program is suitable for single to 3 unit bridge types. For the baking of long spans of more than 3 units, the baking program should be altered in respect to the baking time, temperature, and vacuum release. Baking programs vary furnace by furnace. Thus, modification is subject to the peculiarities of different furnaces. Slight luster reflected on the porcelain surface proves the baking suitable. After the first baking, execute additional buildup to compensate for the insufficient region on the incisal edge. And then, go on baking under the same program of the first baking. Adjust the contact on the proximal, and then proceed to morphological correction with the reference of the same tooth on the opposite side. Dress the tip of a carbon random point sharp for fine morphological correction. If the surface is too rough after morphological correction, no luster may appear on the surface after glazing. Therefore, it is necessary to sandblast the surface with aluminum oxide or grind with gum wheel for the staple luster after glazing. After morphological correction, cleanse it completely with ultrasonic wave. For deficient parts, proceed buildup with add-on porcelain. In this case, we build up the mesial contact and then condense slightly. After drying the glaze for 5 minutes, bake the piece at normal atmosphere from 1202 degrees to 1706 degrees Fahrenheit at a rate of 90 degrees per minute. The baking program of glaze is subject to the number of units. Here is the completion of glazing. It reflects satisfactorily the natural color shade. Then we go on to the stain application after morphological correction. Mix the glazing powder with stain liquid and coat the whole crown thinly. Mix the stain with stain liquid. Apply blue stain on the mesial incisal edge and around the proximal incisal, and orange stain on the lingual incisal area. Mix cervical 3 with orange 2 at a ratio of 1:1 and apply the mixture on the proximal cervical. Then apply white thinly on the line angle of both the mesial and distal side. For the glazing of stain or glazing powder, the high temperature should be 50 to 58 degrees Fahrenheit lower than that of self-glazing. After glazing, MRP is applicable to the shrinkage of margin porcelain. Coat the die with porcelain separator and insert the ceramo-metal crown after glazing. Mix MRP with distilled water or forming liquid and build up on the crevice between die and margin porcelain. Twist the piece off the die and dry it at the table of the furnace, and then bake at normal atmosphere from 1202 degrees to 1562 degrees Fahrenheit. For the excess margin and other rough parts, grind them smooth with a silicone point. We have now introduced you to the fundamental application of Noritake Super Porcelain EX-3. Furthermore, to satisfy the desire of ceramo metal crown, Noritake has developed the luster porcelain, which features the characteristic of opal, and the internal stain, which helps the simulation of the complicated color shade of a natural tooth with ease. Videos for these aspects are also available. I hope it will be of helpful instruction to you. Easy application by dental technicians, smooth completion of ceramo metal crown, these are the aims of Noritake, and Noritake will keep on striving to offer even better and better porcelain materials.